Hi everyone, welcome to my channel. Children, in last class we studied about the various relations between the thermodynamical parameters like pressure, volume and temperature. And this video I will going to explain in detail slope of an adiabatic curve. Slope of an adiabatic curve. Okay, let us try to learn in detail what indicates or what is the use of slope of an adiabatic curve. Okay, slope of an adiabatic curve. Adiabatic curve. So in order to understand the slope of an adiabatic curve, we will consider the equation that is for an adiabatic process PV to the power gamma. So for adiabatic process PV to the power gamma is equal to K or is constant, right? Where P is the pressure, V is volume, gamma is the ratio of specific heat, or it is said to be Poisson's ratio in case of gas. Okay, so we will consider a graph. We will plot a graph by taking pressure along y-axis and temperature along volume along x-axis. Volume along the x-axis, volume along the y-axis we will take the pressure. Okay, this is the origin. Volume is represented by V symbol, P is the pressure. And no doubt you know that the adiabatic curve like that. Now what we will take actually? What we will take here, I will extend further here. You got it, no? Now you should, in order to get the slope, what is the slope actually? Slope is nothing but you know that in general slope is nothing but what you are getting, that in general slope is y by x, or you can say it is dy by dx also, or in other words you can say it is a tan theta, where theta is the angle made by the tangent which is drawn by taking the curve graph. Okay, tan theta also slope. There is so many ways to find out the slope. Now what I will take, I will draw a tangent like that. That tangent meets the volume axis at a particular point. I will take the angle made by the tangent which is drawn to the curve. Let it be theta. What I should do actually? My duty to find out what is the value of tan theta. You got it, no? In this case, value of tan theta is nothing but y by x. This is nothing but your y, this is nothing but x. Along y you are getting dp, along x you are getting dv. Change in pressure, because pressure we have taken along x-axis, volume we have taken along y-axis. You got it, no? So what you should do actually, if you wanted to find out the slope of an adiabatic curve, what you should do actually in this case, try to find out the value of dp by dv. That is the slope of an adiabatic curve. In order to find out that slope, we will consider the equation PV to the power gamma is equal to K. If you call this equation 1, differentiate the equation 1 with respect to t, then you are getting d by dt of PV to the power gamma is equal to d by dt of constant K. You know that d by dt of any constant is 0. So then it is nothing but, you know that d by dt of P or AB, what you are writing, d into, sorry, A into dB by dt plus B into d A by dt. This is nothing but the two formula. One is in differentiation, right? Formula d by dt of AB is equal to A into dB by dt plus B into dA by dt. Okay, now take here A is nothing but P and B is nothing but V to the power gamma. Apply your formula and try to simplify. Okay, now on simplification, what you are getting actually? On simplification here, you are getting now first pressure, right? Pressure into d by dt of V to the power gamma plus V to the power gamma into dP by dt is equal to 0. Okay, 0. Then here you should simplify, right? Here. Then what is the value of d? Now we should find out here P is equal to d by dt of, on simplification you are getting here, in this case gamma into P into gamma into d by dt of V to the power gamma. You should use the formula gamma into V to the power gamma minus 1 into dV by dt plus V to the power gamma into dP, because dt here it is a denominator in the right hand side. If you take this to left hand side, 0 into dt you are getting, so it becomes 0. Now actually our duty to get what is the slope, so at the right hand side we should make the relation dP by dV. Right hand side we should get the relation here. See here dV, here dP. In order to get that relation, what I will do, just I will rearrange P into gamma V to the power gamma minus 1 into dV is equal to minus of V to the power gamma into dP. I want dP by dV. Since dP by dV is nothing but a slope of an adiabatic curve. Okay, my intention only that, how to get slope of an adiabatic curve. Okay, then next what you can think here, for example dP by dV is equal to dP here, dV here, so other things you should bring towards this side. So you are getting P into gamma V to the power gamma minus 1 whole divided by you are getting V to the power gamma along with the minus sign. Correct? Then rearrange P gamma with the minus sign, V to the power gamma into V to the power minus 1, correct, into V to the power gamma. So what you are getting here, V to the power gamma minus 1, V to the power gamma into V to the power minus 1, V to the power minus 1 divided by V to the power gamma. Simplified. See here, P I have written like that, gamma I have written like that, V to the power gamma. You can relate, since if A to the power B minus C, you can write it is A to the power B into A to the power minus C. Okay, same way I have written here. This is the just formula notation. Here V to the power gamma minus 1 is V to the power gamma into V to the power minus 1. Now immediately you can say V to the power gamma, V to the power gamma cancels. What is remaining? You can write since V to the power minus 1 is 1 by V. V to the power minus 1 is 1 by V. Okay, then this equation becomes dP by dV. dP by dV is equal to minus gamma P by V. Minus gamma P by V. Okay, so this is nothing but slope of an adiabatic curve. Slope of an adiabatic curve. Slope of an adiabatic curve. Adiabatic curve. Slope of an adiabatic curve. Okay, and it is nothing but I adiabatic. We have taken symbol that adiabatic is equal to negative of tan theta minus, because here it is negative slope. Negative slope. You got it, no? Negative of tan theta is equal to dP by dV is equal to minus gamma P by V. These are very important relation. Okay, this relation, it is the slope of an adiabatic curve. Okay, try to understand. Now let us try to study more about the slope of an adiabatic curve. More about the slope of an adiabatic curve. Okay, in case of that. Now we got what is I adiabatic. Now we got what is I adiabatic. Correct? In case of that, if you see the I adiabatic is this one, and I isothermal. Slope of an isothermal curve, that is I isothermal. Isothermal is given by negative of P by V. P by V. Negative of P by V. Okay. Now if you find I adiabatic is negative of gamma P by V, I isothermal is negative of P by V. This slope of an isothermal curve I will explain in detail in next video. Okay. Now if you get the relation between I adiabatic divided by I isothermal, it is given by what is I adiabatic minus gamma P by V divided by minus P by V. Then your P by V cancel. Minus becomes plus, so it is gamma. I isothermal. And immediately you can write gamma is nothing but Cp by Cv. Or you can write Cp is equal to Cv into gamma. Gamma. What does it indicate actually? So you can immediately say Cp greater than Cv. Cp greater than Cv. What is Cp? Already you studied. Cp by Cv is equal to gamma. It is nothing but the ratio of slope of an adiabatic curve to the slope of an isothermal curve. If you know what is the slope of an adiabatic curve, if you know what is the slope of an isothermal curve, this is the nothing but the ratio. It is ratio of Cp by Cv. It is gamma. In that way, you can find out what is the value of gamma for a given gas. Find out the slope of an adiabatic curve, slope of an isothermal curve, get the ratio. It will give the value of gamma. What is gamma? Already we studied, it is Cp by Cv. What is Cp? Specific heat of a gas at constant volume, constant pressure. What is CV? Specific heat of a gas at constant volume. So if you write here CP, specific heat, specific heat, okay, what you are getting, SPE, specific heat of a gas at constant volume, constant pressure, CP, okay. What is CV? Specific heat of a gas at constant pressure, at constant pressure. Okay, the ratio of CP by CV is nothing but gamma. It is adiabatic exponent. Okay, so from the relation, you know that now here it is CP by CV. CP is equal to CV into gamma. CP is greater than CV. Therefore, you can write CP by CV always greater than 1. One of the conclusion from the adiabatic curve, slope of adiabatic curve and slope of an isothermal curve. This is one of the very, very significant relation, children, in thermodynamics, because it will give the idea how to calculate the value of gamma, that is CP by CV. Now, from this equation, from the slope of an isothermal process and an adiabatic process, you can immediately find out what is the isothermal process, what is an adiabatic process. Slope of the curve is very, very important to determine a curve is an isothermal or an adiabatic. Okay, for that reason what I will take, in this case, adiabatic is more steeper. Adiabatic curve is more steeper than isothermal curve, isothermal. While comparing adiabatic and isothermal curve, while comparing isothermal and adiabatic curve, while comparing isothermal and adiabatic curve on PV diagram, the curve which is more vertical is adiabatic. The curve which is more vertical than adiabatic, is adiabatic, okay, not than, is adiabatic, it is better, is adiabatic, okay. The curve which is more vertical is adiabatic, okay. Now let me take some examples. Then here, this is the plot what I will take here. See here in this graph, here I will take pressure along y-axis, volume along x-axis, and there is one point I will take. I will drop, there is a perpendicular like that. Then one graph you are getting like that, another curve from the same point like that you are getting. They have given, okay. Now you should find out which one is adiabatic, which one is isothermal. If you look at, this is 2, what is that? This is the first curve, this is the second curve. The second curve is more vertical means almost it will more vertical, or it is relates to vertical curve and its slope is more, then it is adiabatic. So it is adiabatic. And one curve is curve 1 is less vertical and it is almost more horizontal. More horizontal is isothermal, more vertical is adiabatic. So it is isothermal curve. Isothermal curve. Same way, if you take one more thing here, I will draw the graph, similar graph, but in different manner. Okay, here we are taking pressure along x-axis, here we are taking volume along x-axis. Then here point, this is like that, this is like that, and here one point I will take here like this. In volume axis, perpendicular always drawn to the volume axis, already I explained. Okay, then what I will take, in this case, one curve like that, another curve like that, another curve. So if you see, it is arrow marks, very important, arrow marks, because it is a process, right? This is the first process, this is the second process. Curve 1 is more vertical when compared to the curve 2. So more vertical curve is adiabatic and less vertical or more horizontal curve is isothermal. In that way we will differentiate, and later I will explain which one is more, which one is isothermal. You can plot isothermal, adiabatic, isobaric, isochoric curves in the same graph, that I will tell you, okay, in future. Then what you should remember here, these are the things what we should remember. Okay, in that way one can find out what is isothermal curve, what is adiabatic curve, just by knowing or just by looking the graph, just by observing the plot. You can immediately say whether the graph is isothermal, whether the graph is adiabatic. Okay, it is only by comparison. If there are two curves, if it is only one curve, you should say either adiabatic or isothermal. Okay, that is different manner. So this is the conclusion of the slope of an adiabatic curve. In next video, let me explain, I will going to explain the more topics on adiabatic process only. After knowing all the concepts, let us try to solve some conceptual questions which are appearing in your competitive examinations. Okay, thanks for watching the video. Subscribe my channel.